All right, in this lesson, we're going to be solving equations with rational exponents. That means there is a fraction in the exponent. And so one thing to remember is that if you have something raised to the 1/2 power, that's the same as square root. And then anything raised to the 1/3 power, that's the same as cube root. And so when it says check for extraneous solutions, that really only comes into play for square roots. And it really only applies when you have variables on both sides. And so in any of these cases, we probably won't run into extraneous solutions, but we may run into a no solution case because square root cannot equal a negative number. So we always want to watch out for that. And so in this first example, this will be familiar from our quadratics unit. It's just x minus 4 squared equals 36. So we can square root both sides. And then whenever you are using this square root property, you have to do positive or negative. Whenever you are adding the square root to undo a square, it's positive or negative. And so x minus 4 equals positive negative square root of 36, which we know square root of 36 is 6. And so we need to write the two cases. X minus 4 could equal positive 6. X minus 4 could equal negative 6. So we add 4. We get x equals 10. And x equals negative 2. Here we can isolate the cube. So subtract 9. And then we can take the cube root. When you add a cube root, you do not have the positive or negative. That's only for square root. So cube root of 27 is 3. Subtract 1 and you get x equals 2. Here we're trying to undo a 1/2 power, which is a square root, and so we need to square both sides. Subtract 7 and you get x equals 29. And so as you're undoing the exponent, you can think of, if it's raised to a 1/2 power, raise it to the reciprocal power. And so that'll help us later when our numerator isn't a 1. And so here we have a 1/3 power. We can undo that by raising it to a 3rd power. And so x minus 11 equals negative 27. We just undid a cube root by cubing. And then we can add 11. And so x equals negative 16. Here, before we undo this exponent, we have to get rid of this 3. It's not a part of the exponent, and so we need it to go away first. So we divide both sides by the 3, and we get 27, I think, yes. And then now we're trying to undo a 3/2 power. So we undo that by squaring both sides. One thing you want to make sure of is, since this is the same thing as square root, you can't have this number being negative. Okay, and so here we're going to raise to the 2/3 power. Then these exponents would multiply to 1 and cancel out. So that leaves me x equals 27 to the 2/3 power. And so we need to simplify this. And so I think it's helpful to rewrite it in its radical form. So this 3 is the root. So it's cube root of the 27 squared. And then remember, you can root a number before you raise it to a power. And so the cube root of 27 is 3, and then square it, you get 9. Here we have a 3/2 power, but as before, we need to get rid of this 3 first. And we get negative 27. And so this half, this is square root. And so this is telling me square root of some expression equals a negative number. You can't have square root equal to negative, so you would stop here and say no solution. Square root cannot equal negative. Here we have a 2/3 power. Divide both sides by 3 first. You get x to the 2/3 equals 16. And so here, the 3 is a cube root, so we don't have to worry about negatives. And so when we cancel the 2/3 power, we're going to raise it to a 3/2 power. And by raising it to the 3/2 power, this is square root. So we need a plus or minus. Let me get a better color. A plus or minus when we add that square root in. So x equals plus or minus 16 raised to the 3/2 power. You can rewrite that as square root. Square root of 16 is 4. 4 cubed is 64. So we have two answers, positive and negative 64. First step, subtract the 3. And then we can undo this by raising it to the 3/2 power. Because that 3/2 is square root, we have positive negative. And so x plus 2 equals positive negative 4 to the 3/2 power. You can rewrite that using a square root. Square root of 4 is 2. 2 cubed is 8. And so now we have to write our cases. We have the positive 8 and the negative 8. So x equals 6 and x equals negative 10. Okay, and so to summarize, when the numerator of the exponent is 2 or even, any even number, you need to include a plus or minus to undo it. And so that's the square root property. If x squared equals a, then x equals positive negative square root of a. And then when the denominator, of the exponent is even, you need to check for extraneous solutions / no solution, because square root cannot equal negative, and whenever the denominator is even, you're dealing with a 1/2 power.